Welcome to another deep dive. Today we'll be going into the world of logistic regression. And you know what? I'm actually kind of excited about this one. It's one of those tools that just pops up everywhere in data science and AI, and we've got a pretty great stack of articles and videos ready to be unpacked, including some from Google
Oh,
developers.
yeah. It really is a pretty foundational concept. Once you get a grasp of it, you kind of start seeing its applications everywhere.
Right, like it's all about predicting probabilities, the
Mm.
likelihood of something happening. Instead of just giving you a yes or no, it's like, hey, there's a 60% chance that this will happen.
Yeah.
Like that's a total game changer for making decisions.
Absolutely.
Yeah.
Yeah, it's a shift from just predicting like a number, like with linear regression, to actually understanding the chances of a particular outcome.
Okay, that makes sense.
Yeah.
So like predicting my commute time, that would be linear regression. That's a very specific number.
Right.
But predicting if an email is spam, that's where logistic regression comes in and gives us that probability score.
Exactly. And the key ingredient to making all of that possible is what's called the sigmoid function.
Okay, hold on. Before we jump into that sigmoid function, I'm kind of stuck on why we even need logistic regression in the first place.
Yeah.
Like, couldn't we just use linear regression for everything?
That's a great question. And the Google developers video actually does a really good job of illustrating this with a spam filter example. So imagine we're building a simple model that's based on the number of spammy words in an email.
Yep.
A linear regression model might give us a score of, say, like 0.62 for a particular email.
Okay, so now I'm seeing the problem already. Like, what does 0.62 even mean in terms of spam? Like, is it spam or not? That doesn't really help me.
Yeah, exactly. That's where linear regression kind of falls short. It gives you a number that's on this continuous scale, but we need a clear probability, something between 0 and 1, to represent the likelihood of that email actually being spam.
Okay, so logistic regression steps in to give us that crucial probability score. But how does it actually do that? Like, how do we go from a linear model that's spitting out, random numbers to a reliable probability?
That's where the sigmoid function comes into play. It's kind of like the magic ingredient. So picture taking that linear model's output, whatever it might be, and feeding it through this special sigmoid curve. What emerges on the other side is a value that's neatly squished between 0 and 1. So it represents a valid probability.
So the sigmoid function is basically acting like a translator. It's taking the language of linear models and converting it into probabilities.
That is a great analogy. And the shape of the sigmoid curve is super important. It approaches but never quite reaches 0 or 1. So that ensures that the output always represents a valid probability.
Okay, I think I'm starting to get it. But honestly, whenever I hear sigmoid function, my brain kind of just shuts down a little bit. Can you give me a simple takeaway about why this function is so important?
Of course. The sigmoid function is really essential because it translates that output of a linear model, which could be, any number, into that probability score. So, something we can easily understand and use for decision making.
Okay, that makes it a lot clearer.
Right.
So back to our spam filter example. With logistic regression and the sigmoid function working together, we can look at an email with, say, 10 spammy words and get a prediction like, this email has a 70% chance of being spam?
Right. Exactly. And you can even set a threshold based on, your own tolerance for like what gets flagged. Maybe anything above 60% goes straight to the spam folder.
Okay, this is starting to make a lot of sense.
Right.
Now, I know that real-world spam filters are way more complex than just counting spammy words.
Right. They use a ton of different features and advanced natural language processing, but at its core, the concept of using logistic regression to get those probability scores remains the same.
Okay, so we've got this powerful tool that can give us probability scores. But how does logistic regression actually learn from data to make these predictions? In one of the articles, it mentioned a loss function. Does that ring a bell?
Yeah, it does. We talked about loss functions when we covered linear regression, specifically squared loss, remember?
Yeah, vaguely. So is it the same concept here? Like, are we trying to minimize some sort of error?
We are. But with logistic regression, we use a different type of loss function called log loss. And it kind of has to do with the unique shape of that sigmoid curve.
Hold on. Why do we need a special loss function for logistic regression? Isn't minimizing error like the same goal no matter what model we're using?
That's a great question, and it shows you're really thinking about this. See, squared loss works great for linear regression because the rate of change in the output is constant. But with that sigmoid curve, the rate of change actually varies. It's steep in the middle, and then it flattens out at the ends.
So if I'm understanding this correctly, using squared loss with the sigmoid curve would be like trying to fit square pegs into round holes.
Exactly. Log loss is specifically designed to handle the sigmoid function's unique characteristics. So
Hmm.
that gives us a much more accurate measure of how well our model is actually performing.
So this log loss function guides the learning process and helps the model adjust its parameters to become like a probability predicting machine.
Precisely. By minimizing that log loss, the model learns to make increasingly accurate predictions about the probability of, a given event.
Okay, so log loss is crucial for training. Is there anything else we need to keep in mind when we're building a logistic regression model?
Yes. One more essential concept, regularization.
Wait, didn't we touch on regularization with linear regression too?
Yeah.
Something about preventing the model from becoming too complex.
You've got a great memory. And it actually plays an equally important role in logistic regression. We don't want our model to get so focused on the training data that it fails to generalize to new data.
Right. It's like that student who memorizes the entire textbook, but then they can't apply the concepts to a new problem.
A perfect analogy. Regularization helps to prevent this by adding a penalty to the model's complexity. So it kind of encourages it to focus on the most important features for making accurate predictions.
So it's like telling the model, hey, don't get too caught up in the details. Just keep it simple and focus on the big picture.
Exactly. This helps ensure that our model can gracefully handle that new data without getting thrown off by, minor variations.
All right, I think we've covered a lot of ground here. We've gone from the basics of why we need logistic regression to the magic behind the sigmoid function. And we even touched on some key concepts like log loss and regularization.
We have. And next, we'll actually dive into some real-world applications of logistic regression and see how all of these pieces fit together in practice.
Okay, so we've laid all the groundwork. Now I'm ready to see logistic regression in action. Can we go back to that spam filter example?
Absolutely. We saw how linear regression just gave us those confusing numbers. But with the logistic regression, we get those clear probability scores that, actually mean something.
Right, instead of just counting like spammy words, the model's actually learning from tons of emails.
Yeah.
And it's figuring which words or combinations of words are the real red flags.
Exactly. It's kind of like a detective piecing together clues. Maybe the word free by itself isn't that suspicious. But, when it shows up next to money and prize, the model learns that's probably spam.
So it's not just about like the individual words, but understanding the context, like how they appear together. It's starting to sound a lot like how our brains work, actually.
Yeah, it is. And just like how we get better at recognizing those patterns over time with more experience, the logistic regression model keeps refining its understanding of spam as it sees more and more data. That log loss function we talked about helps guide this learning process, and it makes sure the model is constantly, tweaking its internal settings to make more accurate predictions.
It's like the model's going through training, getting better and better at spotting those spammy emails. But how does it actually work in practice? Like, say I get a brand new email. What happens then?
Well, the model analyzes the content, and it scans for, words and phrases it's learned are associated with spam. And based on those clues, it calculates a probability score.
So the model's basically saying, hey, based on everything I've learned, this email has a, say, 80% chance of being spam.
Exactly. And depending on the threshold that you've set, that email either gets delivered to your inbox or it's redirected to that spam folder.
Wow. It's incredible to think that this kind of like probability-based decision-making is happening all around us, not just with spam filters.
It is. Think about credit card fraud detection,
Yeah.
medical diagnosis, even predicting if customers will cancel their subscriptions. Logistic regression can apply to any situation where you need to assess the likelihood of, an event occurring.
It's like it's woven into the fabric of our digital world.
Yeah.
But I have to admit, all this talk about logistic regression and sigmoid functions, it can still feel a little intimidating.
I understand. It's kind of like a new language in a way, but once you break it down, it's really just about using data to understand and predict the world around us. And remember, those Google developer resources that you shared are fantastic for anyone who wants to explore these concepts in more detail.
They do a great job of explaining things in a way that doesn't make my head spin. So what are some other examples of how logistic regression is used in our daily lives? I'm starting to see it everywhere now.
You're right, it is pretty pervasive. Think about those personalized recommendations you get on streaming services or, online shopping sites.
You mean how Netflix suggests movies I might like?
Yeah.
Or Amazon shows me products I might want to buy?
Exactly. Those systems are often powered by logistic regression. They're predicting the probability that you'll click on a certain item or make a purchase.
So behind those, because you watched suggestions. There's a logistic regression model, like churning away, trying to figure out my tastes. That's fascinating.
Yeah, it's all about, creating a more personalized experience, and logistic regression is a really key player in making that happen.
Okay, my mind is officially blown. But now I'm curious about the limitations of logistic regression. No model is perfect.
Right. You're absolutely right. Logistic regression, while powerful, it does have some limitations. One of the key assumptions that it makes is that the relationship between the input features and the probability of the outcome is linear.
Wait, linear. But we just talked about the sigmoid curve, which is definitely not linear.
That's a sharp observation. You're right, the sigmoid function itself is nonlinear, but within logistic regression, the linear combination of the input features is what gets fed into that sigmoid function.
Ah, okay, I see. So if the true relationship between the features and the outcome is more complex and nonlinear, logistic regression might not be the best tool for the job.
Exactly. In those cases, we might turn to some more advanced models like neural networks, which can handle those complex nonlinear relationships much more effectively.
So it's about choosing the right tool for the job, just like a carpenter wouldn't use a hammer to, saw wood.
Exactly. And just like any tool, logistic regression has its strengths and weaknesses. Another limitation is that it's primarily designed for binary classification problems, situations where the outcome is either yes or no.
So it's great for things like, spam detection. But what if we have more than two categories? Like if we're classifying an image as a cat, a dog, or a bird.
Good question. There are extensions of logistic regression that can handle, multiple categories, but it's not always the most efficient approach. Other models like decision trees or support vector machines are often better suited for multi-class classification tasks.
So while logistic regression is a powerful tool, it's not a one-size-fits-all solution.
Right. We need to consider the specific problem that we're trying to solve and the nature of our data before choosing, the right model. That's really where the art and science of machine learning come into play.
I'm really starting to appreciate the nuances here. We've gone from understanding why we even need logistic regression to exploring its inner workings and even acknowledging, its limitations. What would you say is like the most important takeaway for our listeners?
I think the key takeaway is this. Don't be intimidated by the jargon. Logistic regression at its heart is simply about, predicting probabilities, understanding the likelihood of something happening.
And thanks to that sigmoid function, it translates those probabilities into a language that's easy to grasp and use for decision making.
Exactly. Whether it's filtering out spam, detecting credit card fraud, or personalizing your, online experience, logistic regression is silently working behind the scenes, shaping our digital interactions.
It's amazing to think how these seemingly complex mathematical concepts are so deeply embedded in our everyday lives. So the next time I see a recommended for you suggestion or, get an email flagged as spam, I'll have a much deeper appreciation for the algorithms at play.
Exactly. And perhaps this deep dive has even sparked an interest in exploring, the broader world of machine learning.
Yeah, we've only just scratched the surface, but hopefully this has given our listeners a really solid foundation to build upon.
There's a whole universe of knowledge out there just waiting to be explored. So keep learning, keep asking questions, and most importantly, keep diving deep.
It's kind of funny, actually. Before this deep dive, logistic regression sounded to me like something out of a science fiction movie. Now I'm seeing it everywhere I look online.
I know, right? It really is one of those fundamental tools that once you understand it, it unlocks a whole new way of seeing the world.
It really does. But before we wrap things up, I'm curious about the bigger picture. We've talked about, the technical details, but why should our listeners care about understanding logistic regression? What's the so what?
That's a great question. For me, understanding logistic regression, even at just a basic level, it's about gaining insight into how AI makes decisions. It helps us to ask, critical questions about the algorithms that are increasingly shaping our world.
I like that. It's like becoming fluent in a new language. The language of data and probabilities, we can start to kind of decode the algorithms
Yep.
and understand the logic behind those personalized recommendations, targeted ads, and even medical diagnoses.
Exactly. And that understanding empowers us.
Well,
It helps us to recognize both the potential benefits and the potential pitfalls of these systems.
right. Just because an algorithm outputs a probability doesn't mean it's always right or fair. We need to be aware of how these models are trained, what data they're using, and the potential biases that they might reflect.
Absolutely. And that's why I think this deep dive has been so valuable. It's not just about understanding, a specific algorithm. It's about developing a more critical and informed perspective
Hmm.
on the role of AI in our lives.
I couldn't agree more. And, the resources from Google developers that we've mentioned throughout this whole episode, they're a fantastic starting point for anyone who wants to explore further.
Okay.
They break down those complex concepts in a way that's clear and accessible, even for those of us who aren't, data scientists.
Yeah, they really do. And they even offer those interactive exercises that allow you to kind of experiment with different parameters
Hmm.
and see how they affect the model's predictions. It's a really great way to solidify your understanding and gain a more hands-on feel for, how logistic regression actually works.
So whether you're prepping for a data science interview, brushing up on machine learning concepts, or just, curious about how AI is shaping the world around us, I would highly recommend checking those out.
I second that. And remember, this is just the beginning. The world of machine learning is vast and it's constantly evolving.
It really is. But I think this deep dive has given our listeners a solid foundation to build upon.
Absolutely. Keep exploring, keep asking questions, and, never stop learning.
That's a great note to end on. Thanks for joining us on this deep dive into the fascinating world of logistic regression. Until next time.